Okay guys, so we're going to do the exponentials following. These will be on the test, so these have to be the same base, but they're not. So this is 3 to the 3 to the 3x plus 1 is equal to 3 to the 2x. Now, using the power rules, we know if powers are being raised to powers. Since the base is the same, we can set those equal, but powers raised to powers, we multiply the powers. So this is 3 times 3x plus 1, 2x. So this is 9x plus 3 is equal to 2x. We solve. Negative 7x divided by negative 7. X is equal to negative 3/7. Now, with that being said, we do not have to check exponentials because they're defined over the entire x domain, so we should be good to go. Next one, we have 16 is equal to 2 to the 4x. That's 2 to the 4 to the 4x plus 1 is equal to 2 to the 4x. So now that the bases match, we have 4 times 4x plus 1. Okay, so we have these things going on. That's 16x plus 4 is equal to 4x. We subtract 16x. 4 is equal to negative 12x divided by negative 12. This is negative 1/3 is equal to x. Okay, so that's how we get through those two. For the next ones, we do have to check them. So let's do this. Okay. All right, so if we look at this, we have ln x squared minus 5 equals ln of negative 4x. Well, in order for this to take place, that happens only when this is equal to this, so we can do that. X squared minus 5 is equal to negative 4x. Well, we can solve that. We add 4x. X squared plus 4x minus 5 is equal to 0. We factor negative 5 and 4. This is 5 and negative 1, so x equals negative 5. And, sorry, this is x plus 5, x minus 1. Okay, with that being said, negative 5 and 1. Okay, so now we check it. So we have ln of negative 5 squared minus 5 is equal to ln of negative 4 times negative 5. Well, this is ln of 25. We don't know if this is true, so we're checking it. This is going to be 25 minus 5 is equal to ln 20, which is ln 20 is equal to ln 20. So negative 5 is a solution. Okay, but now when we plug in 1, we have ln of 1 squared minus 5 is ln of negative 4 times 1. This is ln of negative 4 is equal to ln of negative 4. Now, you might think that's true, but the problem here is this is negative. You don't have a value. It's undefined. So 1 is not a real solution. And so negative 5 will be your only one for this one. For the next part, B, ln of x plus 4 is equal to, oh, I'm not doing ln, sorry. We have log 3 of x plus 4 is equal to log x minus 4 plus 2. And so this is going to be, first things first, we need to get these all as base 3. So what we're going to do, we're going to act like everything's a power and raise it to that power. So this is going to be x plus 4 equals x minus 4 and then plus 3 squared. Okay, so then this is going to be x plus 4 is equal to x minus 4 plus 9. And then this is going to be x plus 4 is equal to x. Wait, something's not right. What did I do? This should work. Hold on. Let me see. Maybe doing it this way is not the best approach. Let's try it another way. All right. Let's not do that power rule. I'm not sure if that's working. Because I worked this out earlier. This is going to be log 3 x plus 4. Log 3 x minus 4. Well, what is 2 log 3? If we have log 3, this thing's equal to 2, then what goes there? 9. So this is plus log 3 of 9. Right, because this is going to be 2 still. All right, now this is log 3. Okay, so for this to happen, this is going to be log 3 of x plus 4 is equal to log 3 of 9 times x minus 4, because when you add these, you multiply them. All right, so from here, let's do this. We have x plus 4 is equal to 9 times x minus 4, which I believe is x plus 4 is equal to 9x minus 36. Okay, so we minus x. 4 is equal to 8x minus 36. Add the 36. There we go. That's better. 40 is equal to 8x. And x is equal to 5. Okay, so that's taken care of. I was expecting that answer. Now, if we plug that in, does it work? Well, we have log 5 plus 4 is equal to log 3 of 5 minus 4 plus 2. This is log 3 of 9 is equal to log 3 of 1 plus 2. Well, this is 2 is equal to, well, anything raised to the 0 power is 1, so this is 0 plus 2. So we're good to go, and we know this one actually works. So 5 is the actual solution. Okay, and then for the final ones, just be careful with these. They can have any range. Let's do them, get this done. Sorry, I need more space, so I'm going to erase a bunch of stuff. All right, so let's do it. We have the sum. 5x equals 2, 2x squared minus 1. We're going to plug in each value here up until this point and add them together because this is a summation. So what that means is 2 times 2 squared minus 1, that's the first one, plus 2 times 3 squared minus 1. We're just going to plug in the value for anything we see x in this. So we have plus 2 times 4 squared minus 1, 2 times 5 squared minus 1. Okay, so that's every single one of them. 2 times 4 minus 1, plus 2 times 9 minus 1, 2 times 16 minus 1, 2 times 25 minus 1. This is 8 minus 1, which is 7. 18 minus 1, which is 17. 32 minus 1, which is 31. The next one is 50 minus 1, which is 49. And if we add all of this together, 49 and 31 is 80 plus 17 is 97 plus 7 is 104. So this is 104. That would be your solution to this. Okay, and then the final one we have. I'm putting n because I used n here for n minus 3. Those should match. If they don't match, then you can't actually do it. Okay, so that means we have 4 times 1. You can do it, it's just uninteresting. This one is that plus 4 times 2 minus 3. 4 times 3 minus 3. 4 times 4 minus 3. I'm obviously stopping here. You stop there, you start here, you add in between. Okay. This is 4 minus 3, which is 1. This is 8 minus 3, which is 5. 12 minus 3, which is 9. 16 minus 3, which is 12. 16 minus 3, which is 13. 10, this is 15 plus 13, which is 28. And so that is how we do that. I hope this is helpful, guys. Make sure you study, make sure you're ready for the test. You can take it whenever you're ready. You have a couple days to do it. Just do your best. Thank you, guys.